See me. Okay, so we started on Friday with talking about 45, 45, 90 triangles. And we talked about how when you have a 45, 45, 90 triangle, each leg has to have a value of x. And the hypotenuse has to have x times the square root of 2. Then we moved on to 30, 60, 90. And we had the formula where each leg, the shortest leg has a value of x, the hypotenuse has a value of 2x, and then the middle leg has a value of x times the square root of 3. So that was our focus on Friday, about making sure that we understood the difference of those two right triangles. And so I started you guys off with taking a look at this to kind of get you back into the groove of things here. And I'm going to check the... There we go. So that hopefully, you had like a little refresher course on what to do with these problems, okay? All right. So number 1, do I have a volunteer? If not, I'll call on somebody. All right, Jennifer, what'd you get?
32.
32. That's excellent. That's the correct answer. How many people had that? Okay, so about half the class. And then maybe some of you guys didn't raise your hand because you're just not with me this morning yet. All right. So Jennifer, what was your strategy to get to 32?
16 times 2.
Okay. How'd you get 16 out of that?
Because 16 is square root of 3.
Okay, so this leg right here is 16, right?
Yeah.
And so then this leg is 32. Okay. All right. Number 2, what are the angle measures of the triangle? What'd you get?
F.
Okay. So we got F. And that's right. And what's the thing that you probably could have used if you weren't sure? You could have looked back and remember I told you that if you take this side and multiply it by what, that's how you get to 21. Multiply by what? 3. And drop the square root of 3. The other key is this had the square root of 3, right? What if it would have been the square root of 2? Then it would have been 45, 45, 90, or cannot be determined, depending on if it matches up correctly. All right. Number 3. Let's go with Ashley. You got B? Good. Who else got B for number 3? All right. So again, working backwards on this one. How'd you get to that answer, Ashley? What'd you do to work backwards?
I did 44 divided by 2.
Okay. And so then you got 22, but then we talked about in a 45, 45, 90, one of them has to have square root of 2, and so that's where that goes into play. Now, if this one is 22 square root of 2, what's this leg over here?
22 square root of 2.
Yeah, good job. All right. Number 4 gets a little bit more difficult. It's a word problem, right? And again, what have I told you if you have a word problem? What are you supposed to do?
Draw a picture.
Draw a picture. So a square park with side length of 30 feet. Everybody see that? And then it wants to know how far is it to walk across that diagonal. There's 2 different ways we could have answered this, agreed? We could have done 30 times the square root of 2 and put it in our calculator, but what else could we have done? What else could we have used to answer this question? Think back to the first thing we learned in chapter 8. Did anybody use Pythagorean theorem? Couldn't I have done 30 squared plus 30 squared equals x squared? Couldn't I? Yeah, I could have. That would have been one way to do it. But again, you know from knowing that this is 45 and 45, and if these two are the same, then this is 30 times the square root of 2. Well, in our calculator, we get 42.42. So we know that 42 feet is our answer. Why doesn't 21 make sense if we're eliminating answers, by the way?
Because it's way too small.
Yeah, it's smaller, and when the hypotenuse should definitely be what?
Bigger.
Yeah, it should be the longest side. All right. Number 5 is also a word problem that we are going to have to do what for? Draw a picture. Triangle, so it's equilateral, has an altitude of 15 meters. So altitude is this line right here. And so now it wants to know what's the perimeter. Well, if this altitude here is 15 meters, and this is 90-degree angle, what ends up happening is this ends up being 60, this ends up being 30. So if this is 15, what's this right here? It's kind of tough. This is a really hard one. What's this missing that it would need? What's 15 missing? Square root of what? Square root of 3. And so this answer has to have the square root of 3. But when we're working backwards, what do? Multiply or divide? Divide. So what number is going to go in front of this square root of 3? 5. Okay. So if this leg is 5 times the square root of 3, what's this leg right here? 5 times the square root of 3. So we keep going around. What are these two together? 10 square root of 3. So if this whole side is 10 square root of 3, how long is this side?
10 square root of 3.
Okay. How long is this side?
10 square root of 3.
Yeah. And so how long is the perimeter?
30 square root of 3.
30 square root of 3. Okay. My guess is, and raise your hand if I'm right, but some of you may not have been sure what the word altitude meant. Raise your hand if you did not know before, like you didn't know where to put the altitude. Be honest. Okay. So I don't know if you want to highlight that to make sure that when you see that word again, you're not going to have that same issue. Altitude is the height of the triangle. And so that's this portion right here. And I'm going to highlight here as well. Okay? Okay, so we're going to go over 1 through 6. This is focused on the T method and the other method, okay? All right, so Tyler, number 1, what was the proportion you set up to solve for x?
I did 2 over x, and then x over 5.
Okay, 2 over x and then x over 5. Who was able to get that proportion set up for x? Okay, and everybody, which method is this? T method, okay, good. So that's how we're going to solve for x. All right, so what did we get when we did that, Kiara? Square root of 10. Okay. All right, number 2, we got the y method, the L method for y. Chandler, what proportion did you set up?
2 over y equals y over 7.
Okay. 2 over y equals y over 7. And Dakota, what did we get when we did that? Okay. Graciel, what did we do when we got z here?
5 over z equals z over 7.
Alright. And Jaden, what did we get for z when we did that?
Are we supposed to get a square root from
Yep. Did you reduce it to a decimal?
Yeah.
And that's fine. But remember, we talked about we're going to leave our answers in radical form, and then we can switch them if we need to.
Honestly, I would.
Well, what'd you do when you cross multiplied? What do you get here?
35.
Okay, and so then you get z squared equals 35. So then when I take the square root of that, I can't reduce it. So it's just going to be the square root of 35. Okay? Make sense? All right. For 4, 5, and 6, I told you that you have to do y first. Okay? And so if you have to do y first, what is the proportion that I set up for y, Arthur?
Y over 10 and 10 over 20.
So y over 10 equals 10 over 20. Now, the square root thing goes out the window because am I going to be squaring y? No. So I'm going to get a whole number. And what do I get for y, Caitlin? 5. All right. Now, this is where it looks harder than it actually is. You can solve for x already. Why, Denise?
What?
How am I going to solve for x based on what I just did there? If y is 5,
I can take 20 and
mm-hmm,
minus it.
20 minus 5 should tell me how much x is. So Dylan, how much is x?
15.
15. And now I can solve for z. Now I can solve for z. So, let's see, I'm probably back to the beginning. Ashley, what proportion do I have to set up to solve for z?
Z over 15.
Okay.
20 over Z.
That ends up working. It's backwards, but it ends up working. You could also have done 15 over z and z over 20. Everybody understand what I'm saying there? Either way, you're fine. And we've talked about this too in the past, right? This proportion is flipped to the second one, but aren't they the same proportion? Yeah. And so when I do that, I get z squared is equal to 300. Is that right? Alright, and so then when I check the square root of 300, and so I'm just going to remind everybody how to do that. 300 divided by x squared. There it is right there. 10 times the square root of 3. Agreed? Yes? Okay. Alright. Now we're going to take a look at the Pythagorean theorem. And remember, these 4 problems are a review of the Pythagorean theorem. So I'm going to write PT here. What is the Pythagorean theorem? Like, what's the formula? A squared plus B squared equals C squared. Now, when you're solving for the hypotenuse, what are you going to do to the squares? Louder. Add them. When you have the hypotenuse, what are you going to do to the squares? Subtract them. Number 10 is a little bit more difficult because the long side is 8. What does that mean this is? Louder.
4.
Yeah. Good job. Does everybody understand that? Alright, so go ahead and take a couple minutes and solve these 4 problems. Okay, but what did you do to get there?
16 squared plus 32 squared.
Equals?
1345.
Okay. And so when you add those 2 together, you got 1345. And so x squared is equal to 1345. When you take the square root of 1345, can you reduce that at all? No. And so I'm good if that's where you leave the answer. I'm also would have been good with these bigger ones. If you take the square root of 1345 and you can't reduce it, I'm also good if you go with decimals, but how many decimal places are we going to go to? 2. And so I would have also taken 36.67, or yeah, for that one. Because it's also how we can check and make sure our answer makes sense. Why do I know 36 is a good possible answer?
Because it's bigger than both of them.
Because it's bigger than the legs. Okay? Alright. Number 8. Kiara, what did you set up? So 25 squared plus x squared equals 65 squared. So then what does that mean we have to do to these numbers, Sarah? Subtract them. And so when I do 65 squared minus 25 squared, what do I get, Sarah? 3,600. And the square root of 3,600 is 60. And we know 60 is a good number because it's less than the hypotenuse. Okay. Number 9. Jeffrey, what did you set up?
Number 9?
Mm-hmm.
12.5 squared plus x squared equals 25 squared.
Okay. And so when we get this one, what are we going to end up doing with these two numbers, Graciel?
Subtracting them.
We're going to end up subtracting them. Alright, so I'm going to get an obnoxious number. Since I got a decimal, I'm going to be okay if you leave your answer in decimal form for this one. And you guys, when you use your calculator, do you know how to get the number in there by only pressing 2 buttons? Whenever you want to use a number that you've already had before, all you have to do is press second and then press the minus key. You see how there's like the A and S above the negative? That means answer. So like you're going to use your answer to do what you just to do your new problem. And so when I do that, I get 21.65. And 21.65 is good because it's less than 25. And so we know that that's good. All right. Number 10, Chandler, what did you set up for number 10? 4 squared plus x squared equals 9 squared. And so what do I have to do with these two things, Chandler? Okay, so 81 minus 16. X squared is equal to 65. Does that square root reduce? No. So square root of 65. Alright. So that reviews the T method, the other method, and Pythagorean theorem. We also talked about how on a Pythagorean theorem we can square numbers and prove whether or not they're a right triangle. If this is a right triangle, what's going to happen when I square 12 squared plus 16 squared? It's going to equal 20 squared. Well, let's see what happens. 12 squared plus 16 squared, I get 400. 20 squared, I get 400. So, are the squares of the two shorter sides equal to the square of the longest side?
Yes.
Yes. So then this is a right triangle. Go ahead and do the other two. Okay. So number 12, I got 1156 and 1024. So is that a right triangle? No. Number 13, I got 2500 for both. So is that a right triangle? Yes. Now, one thing we want to talk about, that this is completely different than whether or not these are triangles. Because obviously, if we're testing them to see if they're right triangles, are they triangles? Yes, and how do I check and see if they're a triangle? I just add these two numbers, and they've got to be bigger than the third one. So there's a complete difference. If you add the first two and they're bigger than the third, then it is a triangle. But if I'm saying check to see if it's a right triangle, you have to square the first two numbers together, and then square the biggest number, and then you'll know whether or not they're a right triangle. Now, on the quiz you're going to take on Friday, you're going to have a question that says, what is the formula for a 45, 45, 90 triangle? This is what I want you to do to answer this question correctly. Draw a right triangle. Put a 45 and a 45 here. What letter goes with the legs? X. So then the hypotenuse has to be what?
Y.
Nope. X times the square root of 2. So that is the formula for a 45, 45, 90. So then it's going to ask, what is the formula for a 30, 60, 90? So I want you to draw a right triangle. I don't care where the 30 and the 60 goes. But across from the 30, what letter do you have to have? X. And on the hypotenuse, you have to have
X square root of 2.
2x. Right? That's the difference between 45 and 30, 60. And then, because it's a 30, 60, 90, what does the middle leg get? X square root of 3. Okay. So I want you to take a couple minutes, and I want you to answer 17 through 20 using those two formulas we just drew. Alright. So Jennifer, what did you find for X in number 17?
I don't understand
Yeah. Alright, so if this is 45, 45, 90, do you agree, Jennifer?
Okay.
Alright. Let's look up here at our 45, 45, 90 formula. If this is 8, what does X have to be? X has to be 8. Okay? So Tyler, if X is 8, what does Y have to be? 8 times the square root of 2. And you guys also see how this is half of a square? Does everybody understand that? Like, if I take this picture and go like this, now obviously I'm not a good drawer, but you see how that would be a square? And that's the idea, is that you start understanding that these triangles are half of squares. And so this side is 8 and this side is 8. The diagonal is 8 times the square root of 2. Alright, so the same thing happens in number 18. So, Dakota, if the hypotenuse is 9, how do I work backwards to the legs? Don't tell me the answer, tell me what you did. Well, okay, so now tell me your answer.
I got 9 square root of 2.
Okay, so you got 9 square root of 2. I agree with the square root of 2 part. So I'll put that there. What I disagree with is the word number 9. And let's look over here, Dakota. When we had 8 and 8, we got 8 to the square root of 2, right?
Yeah.
So what did we multiply to get that way? What did we multiply by?
8.
Well, no, the 8s are consistent. What's the thing that's different?
The square root of 2.
Square root of 2. So when we work backwards, we have to divide by the square root of 2, right?
Yeah.
So when we divide by the square root of 2, what's that going to do to this number? Yeah, and so we're going to divide by what to this number?
Divide 9 by 2.
Yeah.
Get 3.
Well, we're going to get 4.5. Again, 17 is the easiest of the ones you're going to see. 18 is the hardest of the ones you're going to see. Just remember, when the hypotenuse is a whole number, divide by 2 and add square root of 2. Now, in 30, 60, 90, this switches up a little bit. Jessica, the short side is 32. That's good. That's what we want to start with. We want the short side to be a whole number, because that'll tell us the hypotenuse and the middle leg. So which one you want to give first, Jess?
The hypotenuse.
Okay, good. She got 64 for the hypotenuse. What did you do to get that? She just doubled the short leg. Josie, how do I find the middle leg?
I got
32 times the square root of 3. You just multiply the middle leg times the square root of 3. Okay. Number 20, Ashley. 24 is our hypotenuse, correct? It's a whole number, and that's good. Because we want to just take this 24 and do what with it? Divide by 2. And is that going to give us x or y? It's going to give us x. And so x is 12. Alright? Now, Denise, if x is 12, what's y? 12 times the square root of 3. Okay. Okay. So you guys have been taught about triangles, and we know that we name triangles with 3 letters. And so we have A, B, C. Now, this is where it kind of gets fun. Okay? So, in order for us to do trigonometry correctly, we have to identify the angle we're trying to solve for. In this case, we're trying to solve for angle A. Now, if we're trying to solve for angle A, we have to know 3 terms. We have to know what adjacent means. We have to know what opposite means. And we have to know what hypotenuse means. Let's start with hypotenuse. Hypotenuse is the side that's opposite of the right angle. Everybody agree with that? So the hypotenuse should be the easiest to label when we're looking at these triangles. So this is the hypotenuse. Everybody agree with that? Everybody good? Everybody understand? This side right here is the hypotenuse, which I use the letter H. And it's the opposite of the right angle. Okay, the next one that I'm going to talk about is adjacent. And that is the side next to the angle that we're looking at. Well, if my angle is here, this side is next to it. So it's the adjacent. Everybody agree? Yeah? Okay. And then opposite obviously means the side opposite our angle. Okay. Opposite.
What does it say opposite what?
Hmm?
What does it say opposite what?
Opposite our angle, like whatever angle we're using. Okay. So, in trigonometry, you get to use 3 new words. You get to use sine, cosine, and tangent. And on your calculator, you've had these buttons, and you've probably been staring at them for years. I say years, like 3 or 4. And you've probably called them sin, cos, and tan. Well, no longer can you call them that. It is sine, cosine, and tangent. We use the sine when we are doing opposite over hypotenuse. So when I have a whole number for the opposite and a whole number for the hypotenuse, I can find the angle by using sine. We use cosine when we have adjacent over hypotenuse. And we use tangent when we have opposite over adjacent. Okay. Now, we're going to get ready to do an example of this, and it'll be the last thing we do today before we head out. But I want to tell you that there are 3 ways that you can memorize which one to use and when. I'll tell you the way that I like the least. I'll tell you the way that I like the middle, and then the way that I like the most. The first, and the way that I was taught at first, was to remember this word. So, ka, toa. Like Sacagawea, but like Sokotoa. Now, I don't like that one as much because you have to remember that the H is silent. Sokotoa. The way that Miss McInturf taught a lot of the students in the past was some old horse caught another horse taking oats away. It says, find the sine, cosine, and tangent of angle C. So we're going to put a star or a highlight or whatever in angle C. The first thing that we have to do, the very first thing that we have to do, is determine which of these is the hypotenuse, the opposite, and the adjacent. Well, the easiest one to identify should be the hypotenuse. What number goes with hypotenuse? Speak up. I don't know why I'm only hearing one person.
13.
Yes. The hypotenuse is 13. Which one of these numbers is the adjacent number?
5.
What angle are we looking at? What angle are we looking at because I need to back up. We're doing angle C, right?
Yeah.
So what number is adjacent to angle C? 12. 12 is the adjacent. So then that means that 5 has to be the what? Opposite. Okay? So in order to find the sine of angle C, what 2 numbers are we going to divide? Well, let's go back and remember. Sine is what? Opposite over hypotenuse. So what's our fraction? 5 over 13. Cosine is what? Adjacent over hypotenuse, so that is 12 over 13. And then tangent is what? Opposite over adjacent, so that is 5 over 12. Okay, now I bet you're saying, well, how does that help us find the angle? I'm going to show you this, and then this is where we're going to stop today, so pay attention. In our calculator, when we want to calculate the sine, if you're trying to find a side, then you just hit sine. The problem is we're trying to find an angle, so we're actually going to use what's called the inverse. The second sine, and then you notice how it gave me parentheses? It knows a fraction is going in there. 5 over 13. I hit enter. Forgot to do one thing. I'm glad I brought this up. Everybody go to mode. Do you see how your calculator is in radians? Guess what we have to be in? Degrees. Because we're finding an angle. So we're finding degrees. When you reset your calculator, it'll go back to radians. So make sure that we switch it to degrees from now on. So now I'm going to come back and I'm going to do this again. Second entry, I hit enter. How many degrees is angle C going to be?
22.61.
So round it up, because we're talking about degrees. To do what now? I hit second sine. Alright, so now let's do cosine real quick and see if it matches up. Second cosine, what fraction am I going to put in there?
12 over 13.
12 divided by 13. Did I get the same answer?
Yeah.
Yeah.
Let's check the tangent. Second tangent, what fraction's going in there?
5
5 over
over 12.
12. Hit enter. I got the same. Again, double check your mode. It has to be in degrees.
I have a question.
Yeah.
How come the first two are the same with the H? I don't know
Huh?
how. You know how you did the first one?
Well, because the first one I had it in the wrong mode.
Oh.
I knew I had it in the wrong mode when I got the answer because I should have gotten an answer as a whole number. Okay, so how many degrees is angle C? 23 degrees, right? Angle C is 23 degrees. So now we know angle A is how many degrees? How do we know that? How many degrees are in a triangle?
180.
Right, so if this is 23, how much is angle A?
67.
67. We will pick this back up tomorrow.